And welcome to the new video. So yesterday I announced about my Kubernetes series, and today we are going to take up video one for it. Before that, I would like to tell that there were few suggestions from our viewers, and I appreciate every one of you. The suggestion was from Vinayak that can you please do it on EKS so that we can get a good administration on EKS as well. That's a nice suggestion. Then from Ali, like, can you include cloud topics as well? And if you can add mini assignments or projects at the end of each video for the practice, that's also a very good suggestion. And then there was a suggestion from Mayur that can you include Istio as well. So I have noted all your suggestions and I'll revise my plan accordingly. But and will give this in the description box in the next video, not in this video. But today we because this is a video one and it's just a basic and introduction, so that I'm going to take up. So without further ado, let's go. So imagine you have 100 containers running in production. Who restart them if one crashes? Who scales them when traffic spikes? And who updates them without downtime? If we are doing this manually, it will be a mess. Okay? So, by containers, I hope that we are containerizing the application instead of using it like that. So, I mean that by containers, creating a Docker file and then creating an image and running it as a container. Now, managing containers manually is pain. As you can see, there is some which are crashing, some need scaling, some need deployment. It's not possible to do it manually. What were the problems with traditional deployments? Like if we are talking about the bare metal and the VM based deployment. So apps were directly deployed on the servers or the VMs. Manual scaling was happening, manual deployments was happening, downtime during updates. Problems were hard to scale because it was happening manually, wasted resources, tight coupling with resources, slow deployments. If we talk about virtual machines, so each VM has its own OS, has its own libraries, app. So they are heavy and they are slow to boot. Problems are high resource uses, slow startup, scaling takes minutes. Okay? Why we are understanding it is because we are understanding about the traditional deployments and what were the issues. So when we talk about traditional, there were bare metals, there were like full servers with their own CPU, own hardware, everything. And in virtual machine, they have their own OS, but still they are very slow because they're high resource usage. So it was becoming very difficult. So what happened with containers and virtual machine? Why containers were used? Containers share the host OS. It doesn't have its own OS, but it shares the on wherever container is running, it will share the OS of the host. So they are lightweight, they don't have its own OS because think about virtual machine. So if it is installed on something host, it will again have its own OS. So that was heavy, but containers are lightweight, they are fast startup, benefits are portable, faster deployment, better resource usage. Now, running container is easy, if there are one or two. But if there are many, hundreds of them, then what you'll do to manage it? That's so why containers came into picture. Okay, that I have explained. Now when there are many containers, then how we are going to manage all the containers, that we'll understand. So VM versus container, why containers are used and preferred? Because they are light and fast, and virtual machines are heavy and slow, because containers are using the host OS only, while virtual machine have their own OS. So what if a container crashes? So there are hundred of containers, and if container crashes, or if traffic suddenly increase, or what if a node goes down, or how do we do rolling update? So we need a system to orchestrate containers. To manage the containers, we need any system. That's why Kubernetes was created. So Kubernetes is a container orchestration platform that automates deployment, scaling, and management of containerized applications. Kubernetes service, it has self-healing power, because if any pod or if any application is going down, it will try to self-heal, auto scale, rolling updates, load balancing, and desired state management. If we see Kubernetes high level architecture, so it has a cluster, it has a node, it has a pod, and it is a control plane. So control plane is a main plane which manages all the worker nodes. Okay, it's a master node, you can say, and which manages all the worker nodes where pods are running. But we'll deep understand the architecture in the future videos, not in this video. But this is what, there is a master node, there are worker nodes, and on the master node we have control plane. So before versus, that's all for today's video. I hope it's helpful. Please let me know views in the comment section. Till then, take care. Bye.